Atomic number and mass number, section 4.4. The periodic table can give us a fair amount of information about the atomic structure. When you look at the periodic table and you look at a block with the element symbol, you see two numbers in that block. One number above the symbol and one number below the symbol. The number above the element symbol is called the atomic number. And the atomic number is equal to the number of protons. Always, always, always. The atomic number is unique to each element. You may say, well, what if sodium had 10 protons? Well, then you would not have sodium anymore. You would have neon. So the atomic number, the number of protons always. The number that is below the symbol is the atomic mass. And the atomic mass is the weighted average of all the variations of that element. We're going to learn shortly the word that is the proper word to use instead of variations. When you have a neutral atom, meaning that there's no overall charge assigned to that atom, it's not an ion. Maybe you've heard the term ion from other science courses. I'm going to go through it in a minute. But a neutral atom has the number of protons and electrons the same. So for example, sodium has 11 protons and it has 11 electrons. Now, if you have something that's called an ion is a charged atom. It can either be positively charged or negatively charged, and we will be talking about ions in this class in more detail. Ions differ in the number of electrons because they either lose or gain electrons to get that overall charge. The number of protons stays the same regardless. So for example, neutral sodium has 11 protons and 11 electrons. But the sodium ion with an overall +1 charge still has the 11 protons, but now it has 10 electrons. That plus meaning that it lost 1 electron and has an overall net positive charge. Remember, electrons are negative subatomic particles. So if you lose something that has a negative charge, it gives the overall atom a positive charge. We will talk a lot more about ions later on in the course, but in explaining atomic structure, number of protons is always equal to the atomic number. A neutral atom, the electrons and the protons are the same. The atomic mass is the weighted average of the variations of that element, and we'll see what that means. Variations of that element. Isotopes. Ions differ in the number of electrons. Isotopes differ in the number of neutrons, giving a different variation of that element. Let's talk about isotopes and some terms that go along with isotopes. Mass number. Mass number is strictly the sum of the protons and neutrons. Protons and neutrons equal the mass number. We're going to see that mass number and atomic mass are not the same, they're slightly different. Section 4.5 goes into a little bit more detail explaining mass number. I'm going to break section 4.5 up into two parts, so this video will include the first half about isotopes, and I'm going to make a second video, or another video with the second half of section 4.5, which involves a different math formula, okay? Let's get some of these terms down. Isotopes are variations, are the atoms of the same element with different number of neutrons. So in the previous board, I had written the word variations. Isotopes, okay? Atoms of the same element with different number of neutrons. When you have an isotope, you use a nuclear or an isotope symbol to represent that individual isotope. And the notation is a little bit different than what you look at when you look at the periodic table. We just got done saying when you look at the periodic table, you have the symbol right smack in the middle of two numbers. Number on top is the atomic number, and the number on the bottom is the atomic mass. But when you have an isotope symbol, you have your symbol of the element. And then to the left, you have two numbers. And the number on the top is the mass number, the protons plus the neutrons. The mass number is not from the periodic table. The mass number is the sum of the protons and the neutrons for that individual isotope. Okay, it's not on the periodic table. The atomic mass is on the periodic table, and that's slightly different. We will define that. the number on the bottom is the atomic number. Now, sometimes that bottom number is omitted because the symbol alone can be used to identify the atomic number and the number of protons as well. But standard nuclear isotope symbol notation looks like this. Okay, mass number, protons plus neutrons. Now, let's talk a little bit more about isotopes. Isotopes. Let's look at three variations of carbon. Carbon 12, carbon 13, carbon 14. Carbon 12 is in living organisms. Carbon 13 and carbon 14 are used to for dating archaeological finds, carbon dating. You may have heard that term. Okay, let's look at these three individual isotopes, and from the nuclear symbol or the isotope symbol, let's complete the chart with the following number of subatomic particles: protons, neutrons, electrons, the mass number, and the atomic number. Now, remember, atomic number and number of protons are always the same. So protons and atomic number are always the same. So it's carbon. It has 6 protons, atomic number 6. 6 protons, atomic number 6. 6 protons, atomic number 6. Always, 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 always. Now, these three carbon isotopes are neutral. You say, well, how do you know they're neutral? You don't see any pluses or minuses over here where there would be a charge if they were not neutral. So because they are all neutral, the protons and the electrons are the same. So protons and electrons are the same. So 6 electrons. Okay. Now, these are isotopes, so they're written with a nuclear symbol or an isotope symbol. And remember that the number in the top left corner is the mass number. So the mass number for carbon 12 is 12. The mass number for carbon 13 is 13, and carbon 14, it's 14. Now we need to get the number of neutrons. Well, remember, the mass number, my green marker is dying out, is the sum of the protons and the neutrons. So if we treated this like an algebra problem and we would need to solve for the number of neutrons, the number of neutrons is equal to the mass number minus the number of protons. Okay, so we have the mass number here, 12, and the number of protons is 6, so the number of neutrons would be 6. Carbon 13, the mass number is 13, the number of protons is 6 for 7 neutrons. Carbon 14, the mass number is 14, the number of protons is 6, so the number of neutrons would be 8. You would subtract to get the number of neutrons. Take the mass number minus the number of protons to get the number of neutrons. Okay? Let's do another example with 3 different isotopes, and some of the chart already filled out a little bit differently. Okay. All right, let's say that you are presented with a chart that looks similar to this, that has some information filled out. And you need to complete the chart. You say, okay, how am I going to do this? Well, based upon the principles we have learned in this section and in the previous section, section 4, 4.4.4.5, okay, we can complete this chart. You will need a periodic table to help you, okay? So you can use the one that's in the front of the textbook, or you can use the one I put on Canvas and print it out, any periodic table. Maybe you already have one, okay? Protons are the same as the atomic number. I'm going to write in a different color ink to complete the chart, okay? So what you're given is in green. I'm going to write the rest of it in black. Protons and atomic number are the same. Always, always, always. Now there's no charge affiliated with this. You don't see a row for charge, so the electrons are the same as well. All right, so you have to write in the number of neutrons and the nuclear symbol. Say symbol, how am I going to get the symbol? 43 protons is the same as the atomic number. You're going to look on the periodic table and find atomic number 43. Atomic number 43, okay, remember the atomic number on the periodic table is on the top. Atomic number 43 has a symbol Tc. Okay? 43 is the atomic number, and then the number that goes on top is the mass number. Okay, well, we're given the mass number, 99. Technetium 99 is the isotope. It's used in imaging, x-rays for broken bones and so forth. If you needed an x-ray of a broken wrist or leg, technetium 99 would be used in that imaging. Number of neutrons, the mass number minus the number of protons. So you would take 99, which is your mass number, and subtract the number of protons, 43, and you would result with 56. So all we need is either addition, subtraction, or looking at the periodic table. Okay. All right, we have another isotope here. All right, we're given the atomic number and we're given the mass number. Okay. Well, the atomic number is the same as the number of protons. Yes, 53. Okay. And since there is no charge affiliated with this, the number of protons is also equal to the number of electrons. Okay. Let's write the symbol. Atomic number 53, number of protons 53. Look at the periodic table. It's written in order of increasing atomic number, I for iodine. 53. And what will go on the top will be the mass number. Now the mass number is the sum of the protons and the neutrons. So if you needed to get the neutrons, you would do the mass number minus the number of protons. So 131 minus 53 would give you 78 neutrons. Okay, I'm just going to write here, just for sake of educational purposes, okay, just so you know how that number got there, okay? This isotope, iodine-131, is used in treatment for thyroid cancer. So a lot of these isotopes have medical use, and in the one lab that we're going to do, you'll see that's written in there. So a lot of your isotopes are actually radioactive, but they're in small, precise amounts. They do wonders, especially in medical applications. So if somebody was going for radiation treatments, the radiation consists of some radioactive isotope targeting that specific cancer. And iodine-131 is used specifically for thyroid cancer. Okay. All right, we have one more isotope. Now we're given some different information. We're given the protons and the neutrons. Okay? You say, well, and I know I've been doing this for a long time. I know the questions, okay? And you say, well, if I'm only given this, how can I find that? This is what you always have to be given in this kind of chart. You always have to be given either the protons or the atomic number, either one, because that identifies what the element is. Okay, you have to be given either the protons or the atomic number, as you see in these examples, and you'll see in the examples in the homework problems as well. You have to be given that piece of information. The other piece of information you need to be given is either a mass number or the number of neutrons, because you need one to figure out the other. You need the mass number to figure out the neutrons, and you need the neutrons to figure out the mass number. So you need those pieces of information. The last isotope, we're given protons, 38 protons, atomic number 38, There's no charge, so the electrons are the same as the protons. And now we want to identify the element. So atomic number 38. Okay, atomic number 38, strontium, SR. Okay, we need the mass number. Mass number is the sum of the protons and the neutrons. 38 plus 51 gives you 89. That would also go up here. Okay. Mass number is the sum of the protons and the neutrons. You cannot find mass number on the periodic table. I know sometimes in elementary science or middle school science, maybe even high school, I don't know, but I know that it's sometimes presented that mass number and atomic number are the same, and they're not. But sometimes for elementary purposes, for more of a basic science course, it may be defined the same way. But this is college chemistry, and we're learning, a little more in depth here. Mass number is protons plus neutrons. It is not on the periodic table. Okay, something different on the periodic table, that's atomic mass, and we're going to talk about that in the next video, part 2 for section 4-5.